Hello students, we are on to 1.5 rewriting equations and formulas. So this section, what we'll be doing is we'll be isolating a variable or solving for a variable, but when we do, it's not like we're going to get just a regular number answer. We're going to get some sort of polynomial with other variables in it. The key is when you get to these problems is you're going to look for this solve for something, and in this case it says solve for x. Well, so what that tells me is at the bottom here somewhere I'm going to end up with an x equals, okay? And that's the one rule is I have to get that variable by itself. It's going to be the only thing on one side of this equation, okay? And this is a good kind of exercise for algebra. If you know how to do this well, you really know the kind of technical aspects of how things move around in an equation, and it's a really good kind of almost like a training exercise for algebra, which those words are coming out of my mouth, I realize just how boring it must sound. Like a train, it's not even actual algebra, it's a training exercise. I know, I'm sorry, it's still algebra, and really this is one of those kind of math teacher favorites, one of those types of sections. So here we go. We're going to solve for x, and we're going to do the same thing we've always done. We're going to move things away from it. So we're going to look, and I've got my x right there. So I want to get that by itself. You know, everything you do to one side, you do to the other. I got to get rid of that 2a. So let's minus 2a from both sides. Minus 2a minus 2a. I can't combine my 7 with my 2a, so it's just going to be, we'll put negative 2a plus 7, because we want to put variables first and then our constants. That's just kind of the way things go. And then to get the x by itself, I've got to divide by negative 3. Now when you do that, make sure everything gets divided by negative 3, and that's your answer, negative 2a plus 7 all over negative 3. And that's it. I know this side looks kind of ugly. You're like, Mr. Nimmons, that's totally messy. That can't be your final answer. That's your final answer. That's it. Okay? That's how it's going to look. Let's move on. Example 2. Getting a little trickier, but there's still this solve for x. So I want to get the x by itself. Let's find it. There it is. Okay, we're going to get you out of there, buddy. You hold on. All right. First thing to go is going to be the 2, and then we'll work on that negative 2/3 there, okay? So, let's see, I can't combine anything. You also can combine some stuff occasionally, but not right now in this one. So 2, let's get rid of that. Let's minus 2. Now, if you were thinking plus 2, remember that minus applies to what comes after it. Whatever the sign is, it applies to what comes after it. So if I want to get rid of that 2, there's no sign in front of the 2, which no news is good news. That's a positive, okay? So let's subtract 2 from both sides. I'm going to put my minus 2 under the 4 because they are like terms. Negative 2/3 x equals 4 minus 2, which is 2 minus 2. You know what? I just said let's put the variable first, so I guess I got to do that, even though I kind of had them in order here and all nice and pretty. But 4 minus 2 gives me 2, and then I brought down that 2a. So now I need to get rid of this fraction, and it's a negative fraction. Do you remember how we do this? I'll give you a hint. You multiply by something, and it starts with an O, and it rhymes with opposite reciprocal. Can you think of what that is? That's right, it's the opposite reciprocal. I'm sorry, not opposite, just the reciprocal. Multiply by the reciprocal. Opposite reciprocal is something else. So let's multiply by negative 3 over 2. Because I want to end up with a positive, so negative times a negative gives me a positive. Everything you do to one side, I do to the other. Now, be careful, because when I multiply my right side, I've got 2 terms there. And when you're going to multiply or divide, and say, oh, I got to multiply this side by something, you've got to multiply every term by that thing. Okay, so if I just multiplied one of these, that wouldn't be multiplying the whole thing. So on the left, that all that all cancels out there, becomes 1. I got 1x on the left. Now over here, I've got to distribute that -3 over 2. But what's nice is these both have a 2 in there, and there's a 2 on the bottom. So remember our trick, when we multiply by a whole number, we multiply by the top number. 2 times 3 is 6, and then divided by 2 is 3. And also we've got negative times negative, so that's a positive 3a. On this now, 2 times -3 over 2, 2 times -3 is -6. -6 divided by 2 is -3. There you go. X is by itself. We're done. Move to example 3. We are going to get the a by itself this time. Oh, hold on here. There's 2 a's. We can't get 2 a's by itself. There's 2 of them. But this one, look at this. I could actually combine these two. So keep an eye out for that. Sometimes you can combine some like terms. 3a minus 5a. Well, that's, let's see, 3, carry the 5, -2a. And then I just divide by -2. So don't make this one out to be harder than it is. Also, another little tidbit for you. If I have a negative in a fraction like this, I can put the negative on top, I can put the negative on bottom, I can put the negative out front. It doesn't matter, it's the same thing. It's one negative on it, so any place is fine. Negative w over 2 equals, when we divide this out, we end up with just a. That's it. Boom. Okay, example 4. Okay, solve for a. Oh, there's 2 a's again. Oh, we'll just combine like terms. But wait, we can't. We can't do it, can we? Because this is a 3a and this is a -5ax. And because of that x in there, they are not like terms. I have to have the same exact variables and exponents, so that's different. So, what can we do? Well, let's talk about distributing. So if I had, let's say, an a here, and I multiplied it by 3 minus 5x, we'll say. Okay, if I had to do that, and you'd say, oh well, you rainbow that, you multiply by both parts in there. A times 3, well, that's 3, and then a times -5x, that's 5ax. And we get 3a minus 5ax. Why, Mr. Nimmons? Why do you want to talk about that? Well, guess what? Do you see that right there? This 3a minus 5ax. And do you see this up here? It's the same thing. It's the same thing, isn't it? So what the importance is, why I show that to you, is because we have 2 a's right here, right? But we only have 1 a here. Even though these are the same 2 values, this top line here equals this bottom line here, but this one only has 1 a in it because it represents 2 different a's whenever I multiply the a by each part. So we can use that to our advantage. Are you picking up what I'm putting down here? We can, we'll just say for now, undistribute this and say, well, I've got an a in each part here, so I could put an a on the outside and then put a 3 minus 5x on the inside, and that way I sort of undistribute that. And what the important part is, I have 1a and I can get 1a by itself. If I have 2 a's, well, that's more difficult. 1 though, I can get it by itself. So now, remember when we multiplied by 180? Remember that whole thing? You're like, oh, you just divide by 180. Same thing, let's divide by a here. Or sorry, not divide by a, you want to leave the a there. You want to divide by 3 minus 5x. Because it's a times this whole thing, so I'm going to divide by that whole thing. Divide by 3 minus 5x. 1 second. There we go. I do erase my stuff, make some room. And so on the left side, I end up with 3 minus 5x, or w over 3 minus 5x. And on the right side, this stuff, see how I'm multiplying and dividing by the same thing? That's going to equal 1. Anytime you multiply and divide by the same thing, it equals 1. And so I'm left with just a. Isn't that pretty? I mean, the left side's not pretty, but the A's all by himself. You did it. Well done. Example 5, last one here. So we are solving for A, and there's an A there, and there's an A there. Let's see, I don't have an A on this one. So I've got one, see, look at these in terms of terms. Yeah, in terms of terms. So I've got AW here, and 3A right there, a -7 right there, and a 3AX right there. And I want to look at this, the terms, so each of these is a separate term. Which of my terms has an A in it, and which doesn't? Because that's what I'm looking for. I need to solve for A. Now, that doesn't have an A in it. This does, and this does. So I want to get those on the same side, and then this -7 over on the other side, and then I can do that undistributing thing that we did last time. Okay? Let's do that. That'll be fun. So, add 7 to both sides. That's my first step. Add 7, and I end up with W plus 7 equals 3A plus 3AX. Now, try to beat me to it. Try to go ahead and figure out what goes out here. Whoops, sorry. What goes out here and what goes in here. Okay, I'm going to keep writing this down. You can figure that out. Have you got it yet? Okay, well, we're solving for A, right? So you know the A goes out there. Okay, a little hint for you. Okay, time for the big reveal. So we're left with 3 here because A times 3 gives me 3A. And then A times 3X would give me 3AX. And then I'm going to divide both sides by that 3 plus 3x, divide by 3 plus 3x, and I end up with W plus 7 over 3 plus 3x equals A. Whew. Got it done. All right. Tricky stuff. That is all I have for you today. Have a great one. Talk to you later. Bye.